them a ton. But does anybody know where the term conic section comes from? A cone. Okay, so what does it mean to be a cone section? What does it mean by section, though? A component, okay. So it's like a slice. A section is like a slice. So if you have a cone, okay, so notice here that if I take a plane and I slice this cone, we end up with an ellipse. If I change the angle at which I am slicing it, then notice that I get a parabola there at the bottom, or if I have both of them, it becomes a hyperbola. And if we go exactly across, we end up with a circle. So basically we're slicing cones, and that's where we end up with it. So we've talked about parabolas in the past, but we are going to think about them a little bit more using a geometric idea instead of a function type of idea. So, does anybody know what the definition of a parabola is? Yes, no, maybe. So, this is a parabola, agreed? And what do we notice about our two blue dotted lines? There is two of them. They intersect. This blue dotted line and this blue dotted line. They're the same what? Like, they're both 4.23. Now notice, as I move this point, what happens to both of those? Yeah, so basically, and then what would this point down here be? Yeah, but what is this point in context to my parabola? My vertex. So basically, what your definition, kind of geometrically thinking of a parabola is it's going to be any point that is equal distance from a fixed point, which that's the F stands for focus, and a fixed line, which is going to be our directrix. So let's write that out. So it is the set of points that are equal distance from a point which is our focus, and a line, which we call the directrix. And that equal distance is going to be the p value. So if you notice on there, on our little graph thingy, it said p values for it, and that's because the p value is what we're going to get from our equation, and it's going to tell us how far apart our focus and our directrix are. So, like I said, a lot of this unit is going to be equations and figuring out how to use the equations and what to do with the equations. So first we need to get all of the equations. Now here we actually have two different equations. We have our top one, which says that it has a vertical axis. And notice that the directrix is y equals k minus p. So if we were to graph this, so remember that your axis means your axis of symmetry, but your directrix is y equals, which means that it would be a horizontal line, and your focus would be on the inside. And we've dealt with up and down parabolas in the past. Okay, the difference now is because we're looking at things more geometrically and not functions, it does not have to pass our vertical line test. So we can also now have parabolas that open left and right now instead. So your equation for your directrix is y equals k minus p if it opens up or down. And it's x equals h minus p if it opens left or right. Notice that your vertex is going to be at h, comma, k. So what's the difference between my two equations? Okay, and so what does that mean here? Like, there's an equal sign, so if I were just to, like, swap them left and right, then that wouldn't be any different. But what's different about the left side versus the right side? What does the left side have that the right side does not? It's squared. So, if your x is what's being squared, that means that it's going to be up or down, just like we've dealt with in the past. But now, if your y is what's being squared, that's what tells us that it's going to open left or right now instead. And then the only thing down here at the bottom is basically if your vertex is at the origin, we end up with those two equations. But you don't really need to know those, because if I plug in 0 for h and k, we end up with those. So it's just a specific instance of your equation. So questions on any of that stuff? So let's look at a picture. You don't have to write all of this out, but I just want to give you an idea. So on our first one, notice that our directrix is either below if it opens up, or above if it opens down. And just like before, we have our directrix equations. Okay. But now we also have our focus equations. So you might want to write your focus equations down. And notice that that's going to be the distance, so your p-value is the distance from your vertex to your focus. So notice for my up and down ones, I'm adding the p-value to the y value, versus for our left and right, we're going to add it to the x value. it's basically just going to be using these different equations to help us find information or find equations. So this one says, find the standard equation of the parabola with a vertex at the origin and a focus at 2, 0. So what might it be helpful to do? Yes, but before that we have to decide which equation we're using. So what did we have on the previous page? We had a picture though, right? So what might it be helpful to do here? Draw a picture, do a rough sketch. For most of our conic sections, when we're trying to find an equation, it's going to be helpful to at least sketch the information that we know. So for our focus, where is that located? Where is that at?
It's on the x-axis at 2.
So I'm here, right? Because I've gone right 2 and up or down none. Now, where is our vertex? The origin. Now, from our pictures, where does the focus have to be in relationship to our parabola? Yeah, it was like inside of it, in the middle part, right? So because we know where our focus is, that tells us what direction we have to open. So which way does it have to open? To the right. And that's going to be helpful because now we know which one of my variables needs to be squared. The y value. So remember that if it opens up or down, my x value is what's squared. But if it opens left or right, your y value is what's squared. So we're going to use the y minus k quantity squared equals 4p times x minus h. But do we know what x and h are? Sorry, h and k are? The origin. So that means that both of them are 0. So we just end up with y squared equals 4p times x. So now what's the last variable that we need to plug in for? P. And what did we say that our p value is? Where'd you get to?
Because that's how far away it is from how far away is the focus.
Yeah. So remember, P is the distance that your focus is from the vertex. Which here is pretty easy to figure out that it's 2. However, if I couldn't just see that it's 2, what could we use? Do we recall our distance formula? D equals? There's a square root.
X, add in x values, or no?
X1 plus, not plus.
Minus
yeah,
x2
x2 plus r squared plus y1 minus y2.
Yeah.
That's vaguely
Easy.
I forget it.
So notice here, because both my y values are 0, basically my y part goes away. And then because we have 2 minus 0, we just get 2 squared. But then you take the square root of 2 squared, so you just end up with 2. But, and like I said, in this case it's pretty easy for us to see the distance is 2. But if it was like at 3, 2 instead, then we would want to plug into that formula. So am I just going to put a 2 in front of my x? So y squared equals 2x? Yes? Do we agree? You said p is 2, so I get a 2x. Ah, yeah, so we have to multiply by the 4, because our standard form equation tells us that we have to multiply our p by 4. So we get 8x. Are we okay with that? Be careful, because that's a really common mistake. People just want to stick the p value in front and not multiply it by 4. So that would be our answer. Y squared equals 8x. Questions so far?
So you just leave it as squared, you don't have to square root or anything.
Correct, because like I said, we're not really dealing with like functions this time, so we don't need our y to be solved for.
Okay.
Like when we start dealing with like ellipses and hyperbolas, both your variables are going to be squared, so we don't want to try and solve for things. It just ends up looking messy. Alright, so this one says find the focus of the parabola given by that equation. Not as hard as you think it's going to be. What are the two things that we need to know in order to be able to find our focus? The p-value, because that's going to be the distance from the vertex. Because in this case, our vertex is not going to be at the origin. So we need to know where our vertex is, and then we need to know where what the p-value is, because then we can figure out what our focus is. Does that make sense? Now, what's the problem right now, though?
It's not right.
Okay, what's not right about it?
The
The form is not correct. I agree. So that is not in standard form. But remind me, we've talked about a method that when we have things that we want to make them into perfect squares, what do we have to do? Complete the square. So we're going to have to complete the square. There's going to be a lot of completing the square with our conic sections, like I said, because for our other ones, like our hyperbolas and our ellipses, both terms are squared, so you might have to complete the square for both of them. So we're going to get lots of practice. Now, the first thing we might do is with our equation for our parabola, remember that there's a number in front of my y, correct? So it's okay for there to be a number in front of my y. Specifically, is there a certain number that might be helpful if I multiplied everything by that? What kind of 2? Negative 2. Yes. Because notice, remember, in order to be able to complete the square, the number in front of whatever's being squared needs to be 1. So it would be helpful for us to multiply everything by negative 2. So we get that. So then remember, our first step is to group our first two terms together. And then what is our equation for what we want to add to the inside of our parentheses? Do you remember?
Square. Yes.
That's it.
Yes.
B divided by 2 squared. So what is our B value here? 2. So 2 divided by 2 is 1. 1 squared is 1. So that was the missing piece for the inside. But then, are we allowed to just add a 1 because we feel like it? No, we have to balance out our equation. So what do we also have to do? Subtract a 1 from the outside as well. So then remember, our whole goal or point is that we want to factor this quadratic, but we want it to be a perfect square. So if we don't end up with a perfect square, we did something wrong. So what multiplies together give me 1, that adds together give me 2. 1 and 1. So we get something that's a perfect square, like we were supposed to. Yay! And then what do we get on the outside?
Multiply by. Yeah.
So now, remember that our conic section form of our parabola is a little bit different than our function form of a parabola. Because remember, with our function form, it was just y equals a, and then we had like a number on the inside and a number on the outside. Agreed? But with this one, we don't want a number on the outside, right? We just want something squared, and then this minus 2 needs to be with our y. Agreed? We all okay with that? So then how would I move it over to be with my y? Just add it. And then our last step is going to be, we want the leading coefficient of our y to be 1. So you need to factor out whatever number is in front of your y. So now, where is our vertex at? Vertex? Nope.
Negative 1, 1.
Negative 1, 1. Because remember, it's the opposite side of whatever's on the inside. My h is still with my x, and my k is still with my y. So it would be a negative 1 and then a 1. But that's not what they asked us for. What they asked us for? The focus. So what did we say we have to know in order to be able to find our focus? The p-value. So negative 2. Is negative 2 my p-value? No, negative 2 is what? 4p. So then what would the p-value be? Negative 1/2. So then we have to decide, do we want to add that value to our x or to our y? So what's our graph look like? Which way is it going to open? Remember, if my p-value is negative, it's going to open down, right? So my x is what's being squared, so it has to open up or down. But if I have a negative in front of my x squared, right, it opens down instead. Agreed? And we said that our focus has to be on the inside, right? So it would be below it. Agreed? So it's going to be the y value. Anytime that it opens up or down, we're going to add that p value to the y value. So what would we get? My negative 1 stays the same. And then if I add negative 1/2 to 1, we get just 1/2. So really, the hardest part of that one was just completing the square. But then from there, like we said, we're just using these different formulas to basically figure out the information that we need. Questions over any of our steps? Yeah. This part? So remember that that is just what our equation is. So remember, whichever one is not being squared, the number in front of it equals 4p. But since we want to know what p is, that's why we have to divide by 4. Does that make sense? Other questions about where any of the numbers came from or how we got them? Yes? No? Me? How did we get this?
The half of the 1/2.
Here? I took my p value. And I'm going to add that to the k value.
Oh.
Because we said that it's going to be below my vertex, right? And remember that p is the distance that my focus is from my vertex. And because it's below it, we added the p value to the y value. Does that make sense?
Yeah.
Other questions? No? Okay. Alright, so this one says, find the standard form of the equation of the parabola with a vertex at 2, 1 and a focus at 2, 4. So again, what might it be helpful to do first? Draw a picture. So, what quadrant is our vertex going to be in? Top right, which is your first quadrant. Remember, they go counterclockwise, so top right is 1, going to the left is 2, bottom left is 3, and then bottom right is 4. Okay, and then our focus is going to be in which direction from our vertex? Up, down, left, or right? So that means that our parabola has to open which direction? Because remember, your focus has to be on the inside of your U shape. So if it's opening up, which one of our variables is being squared? Think about like our normal quadratics. If it opens up or down, which one of our variables is squared?
Yeah.
X is what's being squared, yes. So that means that we're using this formula. Well, do we know what H and K are? What are they? So that means they're going to be 2 and 1. And we have to figure out what P is, but they gave us the focus. So what does P equal? 3. So then we plug in 3. So what do we get in front of our Y? Well, and that would be our answer. Questions so far? So then the last thing that we might have to do would be to graph them. So if we wanted to put this in standard form, what would we need to do? Fix it. Okay, how so? We don't have to complete the square this time because my x is already squared, right? So that's nice. What do we have to do? So we would subtract 5, right? And then what do we need to do? Yeah, which is the same thing as multiplying by 1/3. So that would be standard form. So where is our vertex? Okay. Where is our focus?
Good question.
That is a good question. It's like one that you might see on your homework or your quiz. So we might need to know how to do it. So which one of our variables is being squared? The x. So if my vertex is at 4, 5, and the x is what's being squared, okay, and my p value is going to be negative, which way is it going to open? Down. Now, remind me, what does this 3 do in the front of my x? What do we mean by bigger? Does not make it wider. It makes it narrower. It does stretch it, but remember it stretches it from our x-axis, so that's why it makes it taller. So, where does my focus have to be? Inside. So that means it's going to be below this, right? So what do we have to know in order to be able to find that? The p-value. So is my p-value negative 1/3? You would divide it by 4, which is the same thing as multiplying by a fourth, so we get negative 1/12. So then we would add negative 1/12 to our y value. So what do we get?
4 comma.
Like that? Is that what you meant? Okay. So then what about our directrix? So it's going to have to be above it, right? So you would actually subtract it, which ends up being addition. So let's graph that. My focus is going to be slightly below. My directrix is going to be slightly above. What type of line is that? Horizontal. So is it going to be x equals or y equals?
Y equals.
So we have y equals 5 and 1/12. Or you could switch that into an improper fraction as well. But either way. Yes? No? Maybe? Yes.
Would you get the 1/12?
So remember that to find our p-value, we have to take the number that's in front of our not squared thing. So in this case, negative 1/3. And then you would have to divide by 4, which is the same thing as multiplying by 1/4. So that's why we get p equals negative 1/12. Does that make sense? Okay. Other questions? So we think we can do one on our own?
Yes.
I like our confidence. Alright. So, we have this. What are we going to need to do first?
Subtract 10. No.
What do you need to put it in?
Standard form.
Standard form. You're going to need to complete the square. But which one are we completing the square with this time? Your y value is what you're completing the square with. And then graph it. Go forth. It's going to be on your test, in your homework. That's fine. Look at the same thing. She just wants it on the other side. So you do it either way.
squared.
Plug it in.
What do you add?
You do the
Remember, p divided by 2
which
squared. So
is
you get 4.
4.
So yeah, that's the inside of the parentheses. Correct? No. Just one. Just one subtract 4. So then what does y squared plus 4 y plus 4 factor to? Find the square. And then you're just simplifying.
Oh.
So remember our equation is b divided by 2 squared. So we just take 4 divided by 2 squared. So we get 4. We need to add 4 to the inside of the parentheses. Add 4.
Oh, I love it.
Wait, I was right.
Right? But then remember, for our conic section form, we want our y squared stuff to be by itself. So we would subtract 6. And factor out a 2. So our graph is going to be going right because our p value is positive and our y is what's being squared. Now, what is our p value? 1/2. So that means that my focus is going to be 1/2 to the right, and my directrix is going to be 1/2 to the left. And that would be our answer. Questions on any of those steps? Yes. Where did I get the what?
Y squared plus 4y plus 4.
This one? So remember that our formula is b divided by 2 squared. So 4 divided by 2 is 2. 2 squared is 4. So that's what goes on the inside. And that's what we want to use when we complete the square because it's going to make it a perfect square. Other questions? Yes.
The vertical line or
Directrix.
horizontal,
Yeah.
You have to include that every time, right?
You have to what?
Include that every time in the graph.
I mean, if it asks you to graph it, yeah. I did just because there will be questions where it asks you to find it or to graph it, so just good practice for us. But if it doesn't ask you to, then no, you don't have to. No. So like on this one, notice that we're used to thinking about a values, which are in front of our squared stuff, right? So if I divided by 2, that would give me 1/2, right? So 1/2 is what's really affecting my y. So that's going to compress it, which makes it wider. But remember, because we are left and right this time, it makes it wider going up and down this time. So like for the most part, what I'm going to be checking is 1, is your vertex in the right spot? 2, is it opening the correct direction? Up, down, left, or right? And then 3, if I have a 6 over here, it should be really wide. If I have a 1/12 over here, it should be really narrow. Am I going to get super specific with it? No. But do I want to see that you've at least thought about this should be wider, this should be narrower. Yes, that's mostly what I'm looking at. Other questions?
The plus 6, where did that?
10 minus 4.
Oh, okay.
I just simplified.